Hello and welcome to Season 2, Episode 4 of LogiCast. I'm Karl Robinson, CEO and co-founder of Logicata, and I'm joined, as always, by my colleague, John Goodall. How are you doing today, John?
I'm okay. I'm all right. I think I have an addiction to buying sheds, but I haven't bought anything yet.
Have you bought another shed?
No, I spent a good chunk of yesterday looking at bike sheds and,
Oh,
kids' bikes and stuff.
is that to go behind when you're feeling frisky?
That's a chemical shed, isn't it?
It's behind the bike sheds.
Was it?
That's where
Showing
all
your
the
age
action
now. We all
used to
got
take
driven to
place
school.
Yeah, I never had a bike, but yeah, actually had a bike. I didn't ride it to school. Anyway, we're not here to talk about sheds or bicycles. As if you've listened to the Logicast podcast before, every
We
week
do talk about sheds and bicycles.
we do talk. I think that might be our first feature of bicycles, actually. But typically, we're talking about AWS and AWS news. So once a week, I curate a list of AWS news, which I distribute via my weekly AWS News Roundup newsletter. And then John and I select a subset of those articles which we want to talk about in a little bit more detail. So we've got another 5 articles to chat through this week. And the first of those is not about serverless. If you listen regularly, you'll know that we talk a lot about serverless. And of course, we will be talking about serverless later on in the podcast. But our very first article is actually about Amazon EC2 Launch Templates now supporting Systems Manager parameters for AMIs or AMIs, or what is the correct way to say AMI?
I don't know. I
Maybe
know
long
that
form. Amazon Machine Images.
it's an Amazon machine image. It's an AMI. It's an AMI. I don't know. I swap between them depending on who I'm talking to. Like if I know the other person has a preference, I'll use their preference. If I know that they don't know what they are, I'll use the long form acronym. Having explained the acronym because it's easier for people to keep up. But
And how do you know their preference? Is this something you ask at the beginning of a conversation? We're going to talk about Amazon Machine Images today, and I'm just curious to know if you prefer AMI or AMI.
Maybe a little bit less stuffy than that, but sure.
So anyway, let's talk about Amazon EC2 Launch Templates now supporting Systems Manager parameters for AMIs.
Let's talk about my cat being in the way. So Systems Manager is a collection of services that kind of fit together. Hence, you talk about Systems Manager Op Store, Systems Manager Parameter Store, that kind of thing,
Loosely
right? It's a collection
coupled.
of kind of, yeah. It's all the sort of things that a sysadmin back in the day would have found useful, and they've kind of just sort of put them all in one place, if that makes sense. They're not odd bedfellows, but it's not necessarily a holistic service, if you like. So that's Systems Manager.
Family.
Yeah. But they just called it one service because each one thing by itself isn't necessarily big enough to be a service. Inside Systems Manager, you have Parameter Store, which is, it's what it says on the tin. It stores key value pairs, right? The key can be a certain size, 64 characters or 256 characters or something. And then the parameter can be, depending on whether you're using the free tier or the paid tier, up to 256,000 characters or something like 10,000 meg or something like that. Not that big, but there's options, right? And then they have strings and secure strings, and then you can do numbers and various other bits and pieces. So you can do encryption and stuff in there too, which is cool. A common use case for SSM, Systems Manager, Parameter Store, SSM Parameter Store, or just Parameter Store, is storing parameters, obviously. One of the key things that you might want to store is a golden image reference. We have built this server image, this contains our application, this contains PHP, Laravel, Nginx, whatever, for a web app. And you store that AMI, store that AMI. You see, I swap, I do. And you then put a record to the ID of that in a parameter somewhere. You could put it in Dynamo, you could put it in Parameter Store, you could put it wherever. Parameter Store is a common design pattern because it's free for the free tier, and this is one of those always free. So you just leave advanced parameters off, and I think you have 10,000 parameters for free or something silly. It's like, so it doesn't cost anything, so people use it because that's kind of what it's for. Inside parameter store, you can, well, not inside, CloudFormation, and I think Terraform as well to an extent, but CloudFormation does it better. You can resolve those parameters inside your templates with this slightly obscure syntax that looks a bit like the ARN. It's got the ARN in it, and you've got resolve and some curly braces and stuff around it, right? And at deploy time, CloudFormation would resolve that, go off to SSM parameter store, get the value, pull it back. Great, lovely, we like that, because then you just kind of put it there and it updates at deploy time, and every time you deploy it, it changes, and that's fine. What this is doing is that's moving that functionality, or rather is adding that functionality inside the launch template setup, such that you can put the parameter in the launch template with a bit of this resolve syntax, and then just put that launch template up. So rather than CloudFormation doing the resolving, it's the launch template doing the resolving. So whenever you rebake your AMI, you don't have to redeploy. It's just up and it's done, and the value's in SSM, and then the launch template is aware of it. So then the next time you get an instant spin up off of that launch template, it's up to date. Happy days.
So it's just making your life easier, effectively.
Yeah, it's not a shift left so much as a shift right, which is a bit weird, but I like me likey. I will probably see, fending off your questions. I can see me using this for certain customer engagements where we have visibility of their build process as well.
Well, I don't know what to say now, because I was going to ask you the question, will you use it? And now you've just stolen my thunder. So
He stole my thunder. Give it back.
So thanks for that. Thanks for that overview. So let's move on to our comfortable stomping ground of serverless. So we talk a lot about serverless on this podcast because it is in vogue right now. But I guess we've never really done a back to basics, and that's essentially what this article is. It's a high-level overview of AWS Lambda functions. It's an article on DroidMen called AWS Lambda Functions Unlock the Potential of the Powerful Tool. And it goes through a whole bunch of things: an introduction to Lambda, the benefits, common use cases, how to set them up, security tips, best practices, optimizing, integrating, troubleshooting, and debugging of Lambda. So I don't know if we're going to be able to talk about all of that in 5 minutes, but we'll give it a go. So, John, what do you want to say about Lambda?
Oh, it's my favourite thing. Oh, I love Lambdas, me. So calling this an article, I think, is a little generous. It's more of a listicle, if you like. And I might have to let my cat out.
I did see
apologies
clawing at the door in the background there. So apologies to anyone who's listening and not viewing the podcast. You'll have missed out on that the treat of John's cat trying to exit his shed.
Oh dear. Really must put a cat flap in the window or something.
Yeah, back to the listicle.
Back to the listicle for the listeners. So Lambda, this has a table of contents on this listicle of, what they are, benefits, common uses, setting them up, security, best practices, optimizing, integrating, and troubleshooting. What I'm going to do is I'm going to skim through each of those and try and do them in 30 seconds or less. Sound good?
Would you like me to do a countdown?
Go on then.
Well, that might put you off though, mightn't it? But I could actually set a 30-second timer on my phone and see how well you do it.
Yeah.
Let's have a look. Timer. 30 seconds. Are you ready?
Go on then.
Go.
Right. Lambda is a, quote, serverless compute service, quote. We've defined serverless on this podcast a lot, but the short version is, yes, there's a server there, but you just don't have to worry about it, right? Lambda supports a bunch of different programming languages and Docker for arbitrary languages, and the great advantage of something like this is you don't have to worry about provisioning the servers and making sure that they're up and available and online and HA and so on. You just say to the service, I would like X amount of RAM and Y amount of CPU, here's my code, go.
Time's up. Well done. There was no notification sound there because I accidentally set the timer for 1 hour and 30 seconds. Thankfully, I kept my eye on it. Otherwise, we would have completely ran over time. So now you want to do the second one, yeah? Benefits of using Lambda in 30 seconds. Go.
So, like most serverless things, it's pay for what you use. And because you're not really using huge amounts of compute, you don't pay a lot. The free tier is incredibly aggressive. It's like 400,000 compute seconds or something silly. It scales ridiculously. It'll add, like, I think one function per second for up to an hour or something mad. It's HA by design because you have to worry about it. Reliable and fast deployment, just to kind of pinch from the article, because you're not having to worry about all of those stuff, all that stuff.
There we go. Well done.
Cool.
So now we're going to get on to common use cases for Lambda functions in 30 seconds. Go.
Anything you like, realistically. It used to be a little bit limited in that it was kind of viewed as this sort of glue code, so you could sort of mush things together. And to an extent, it's still viewed by people that haven't really worked with it. But anything you like. You can do serverless websites. Composer and Laravel works with it quite well. You can do video processing, machine learning, and still the glue, I think. The glue is still quite common.
Oh, that was less than 30 seconds. Well done. You didn't even use the full allotted time there. So can you tell us how to set up a Lambda function in 30 seconds? Go.
So the article is telling you how to do it through the console, or through ClickOps, as we like to call it, which is pinched from Corey Quinn, but I like the term, so I'm going to keep using it. Wouldn't recommend doing that. You can do it through Terraform, but that's hard. You could do it through CloudFormation, or better yet, you can do it through SAM, Serverless Application Model, which is much easier because it deals with the zipping and the MD5 sums and all that jazz. You can do it through the Cloud Development Kit, or you can do it through serverless.yaml. So realistically, write some YAML.
Brilliant. Bang on time again, John. You're good at this. Your
loving that
internal
sound.
clock. Your internal clock must be very effective. Either that, or you have this amazing ability to speak and count down 30 seconds in your head at the same time. So 30 seconds then on security tips for AWS Lambda functions. Go.
This is no different than anything else. You just it works in a zero trust model quite nicely. IAM roles and policies to control what it can access, and that is great because it limits blast radius, so you don't have to worry about someone kind of taking over that role, and that role just does what it's need to, so least privilege. You don't have to put it in a VPC, and you do pay more for putting it in a VPC if there's traffic in and out, but you can do. And then the usuals, things like CloudWatch, CloudTrail, Guard Duty, the usuals. I love that noise. That's great.
That's just the default little robot timer thing on the iPhone. Other phones are available.
Not by Amazon, not anymore.
So now I'm so focused on timing, I've lost where we are. We're on best practices, aren't we? Yeah. So here we go. 30 seconds on best practices for managing AWS Lambda functions. Go.
These are the same as every other best practice for every other development project, every other application you've ever worked on. Keep it up to date, keep it patched, automate your deployments, automate your testing, externalize your code, so reusable functions. Lambda implements that through layers, so use layers, and try not to orchestrate too much inside a Lambda. Use something like step functions for that.
Wow, that was only 20 seconds. That's very
Should
impressive.
I spend another 30 seconds explaining what step functions is?
No, that's another podcast. But you can spend another 30 seconds talking about optimizing Lambda functions for performance. Go.
So X-Ray is good for this. Integrate with X-Ray. Do your tracing so you can see where the bottlenecks in your system are. Put as little as possible in the handler function, because the handler function is non-reusable between executions, but everything else is. So reuse code means your cold starts are faster. And then everything else is kind of the same. It's used caching. It's used databases effectively. It's use SQS and palm things off for asynchronous processing, yada, yada, yada. Before we move on, I am going to take exception to one thing in that list. It says use Aurora serverless for database access. That's nonsense. That's a nonsense. You can use any database you like, but Aurora serverless is fairly performant. That being said, it's not as performant as DynamoDB, but then Dynamo is a NoSQL database and Aurora serverless is still a a relational database. So it's a reasonable thing to say, but I just take exception to it as a rule.
Horses for courses.
Yeah, use the database that's appropriate for your workload. Don't go, oh, this listicle said use Aurora serverless. No.
Fair enough. So 30 seconds on integrating Lambda functions with other services. Go.
So I'm going to go off script a little bit here. Lambda will integrate with pretty much every service in AWS, either natively or through a little bit of jiggery pokery. The article says things like SNS and SQS and Dynamo and API Gateway and so on and so on. If you can think of a workload, probably Lambda can be directly triggered from it. And it will be able to talk to it on the other end, either through the results section or just by calling the API.
And finally, 30 seconds on troubleshooting and debugging AWS Lambda functions. Go.
Functions log to CloudWatch logs by default. They have to. They can't not. So, well, I mean, they can, but you just log there. So you've got your logs by default. Lots of logs we like. I've said X-ray already, but integrate X-ray because you get service traces. You can also do alarms based through CloudWatch based on the status of the function, and then you can either look at that through CloudWatch or sling it off to PagerDuty or something like that. And then again, automate your deployments such that if you do need to make a fix, it's quick, it's easy.
Bang on. Very good, John.
Bang on. That was an advert for something, wasn't it?
Probably. I don't watch TV anymore, so my knowledge of adverts tends to be more from the 70s and 80s. So I try to avoid them where possible these days. But thanks for that. So even though we limited each of those points to 30 seconds, we probably spent way more on that article, way more time on that article, than we should have done. But that was an excellent overview of Lambda. So let's skip on and staying loosely in the theme of serverless. With the next article is another from the Let's Architect series on the AWS blog about designing event-driven architectures. So I know before we came on air, John, you were telling me how much you love event-driven architectures. So tell us what it is that you love so much about event-driven architectures.
There's just a lot less. Well, how can I word this? There's a lot less for you to worry about, but you just worry about different things, if that makes sense. With an event-driven architecture, I mean, the blog post has a synchronous versus asynchronous kind of UML type diagram, which is really helpful. With a synchronous setup, client makes a call to service A needs service B might need service C, and so on and so on. Right, and then everything calls the next thing, and then it rolls back up the chain, and eventually the client gets told that, yeah, great, you're done. But the client couldn't do anything whilst that was going on. Asynchronous asynchronous processing has been a theme for a very long time. It's just not been a formal kind of design pattern, if you like. It's always been, take things offline for processing. And that's kind of the idea. Client calls service A says, yep, I've got your request. And you will be told via a notification when it's done. You can go off and do something else while you're waiting. Wonderful. Service A calls service B might call service C, and so long as they don't require the outputs from each other directly, they can just sit there, do their processing, and then sling it back to the client or sling it back to an aggregator, which will then sling it back to the client. So generally, it's more efficient because you're not sitting there waiting and you're not using user time and user attention span, which is, particularly in this day and age, a rare commodity. Getting them to sit there and wait for something, I think what's the numbers these days? If it takes more than 30 seconds for a web page to load, people are gone. Not even that. It might be 5 seconds.
I thought it was about 2 seconds or something.
It might be. It's gotten shorter and shorter and shorter over the last 10 or 20 years. It's people have no patience anymore. So if you can tell someone, yep, we're doing that in the background, it'll take a little while, but we'll let you know when it's done. You can go off and do this other cool thing in our app, then they're much more likely to stay on. And if they don't, notifications are the best way of getting people to come back. Because we've done this thing you wanted, come look at it. And then people will, because it's that dopamine rush. It's that, oh, here's a thing. So it kind of helps with that. It does help with engagement, but engagement just looks a little bit different than it used to. So there's that. And then on top of that, with event-driven architectures, particularly in AWS, because there's so many services that will talk to other services without you having to manage and configure things. I'm thinking SQS, I'm thinking EventBridge. You can just kind of hook it all together, and you don't have to worry about it. It just does it. Speaking like a true millennial, you don't have to worry about testing it. Yes, you do, but you don't have to worry about managing it, which we like. And the orchestration, it's a little bit to get your head around from a designing perspective, but once you've done that, it's a whole heaps easier to deal with.
I had a quick Google. Other search engines are available.
But they're all rubbish.
The ideal website load time for mobile sites is 1 to 2 seconds, and 53% of mobile site visits are abandoned if the page takes longer than 3 seconds to load. So it's a very short window of time you've got to display your web page or your update your web app.
Yeah, and the thing with, you can even do websites event-driven like this, so you kind of load the skeleton in to get something there, and then you start loading the background content whilst the user's looking at the foreground content, or whatever. Infinite scroll is a good example of this, is you just keep scrolling down, and as you scroll down, it's loading things in the background. It's, the system knows that you're there, so it's preloading things as you're going.
It knows what you're going to do, because the only thing you can do is scroll down. Yeah. Cool. All right, let's skip on from the world of serverless and event-driven architectures into a little bit of automation of incident responses, which is obviously very relevant in our world as a managed service provider. We're responding to lots of incidents on a regular basis.
Well, some.
On behalf of our customers. Some incidents. Obviously, it's our job to make sure the environments are so well managed that there are very few incidents, but occasionally the proverbial does hit the fan, and therefore it's important to be able to respond to incidents. So this particular article is about how to automate incident response with PagerDuty and AWS Systems Manager Incident Manager. So we're back onto another member of the Systems Manager family. This time it's Incident Manager. PagerDuty, of course, something that we use ourselves in LogiCast. So tell us about this one, John. Automating incident response with PagerDuty and Systems Manager Incident Manager.
I'm surprised you didn't trip up on that. That's impressive.
Yeah, I practiced it a few times yesterday while I was reading it in the mirror. Yeah.
All right, so let's do the usual. Excuse me, and let's do a couple of definitions. So PagerDuty, for the uninitiated, I envy you, is a way of getting on-call engineers out of bed, primarily. Right? It will call your phone, it will text you, it's got an app, it will ping you, it will override the do not disturbs and all that kind of thing. It will get someone out of bed if it's configured properly. Cool. And it's also the cause of PTSD in many SREs. Yeah. Incident manager
Are you going to elaborate on those TLAs?
That's an FLA, isn't it?
Well, one of them was, and one of them was a TLA, but
yeah. Post-traumatic stress disorder within site reliability engineers.
Thank you.
I.e., the people that got woken up by it get really kind of scared of it. I mean, I had full-on burnout from it at one point. Had to uninstall it from my phone, and took like a year to get over it. It was awful.
It's the kind of sound that you hear. You get phantom PagerDuty notifications.
Oh,
The kind of sound that you hear when it's not really there. Was that PagerDuty?
So that's that. Systems Manager Incident Manager is an AWS tool for collating incoming events and alerts and so on into a central dashboard. PagerDuty itself can do this, and it's relatively good at doing this, but to get proper benefit out of it, you have to go to quite an expensive tier within PagerDuty. So it's worth saying that it's not the only thing out there that does this. PagerDuty itself will do this, but Systems Manager Incident Manager is quite a bit cheaper at kind of low scale. There's a few things it does do, as I say, but the primary thing it does is it gives you this nice kind of dashboard, and it takes in event feeds from things like CloudWatch and EventBridge and all that kind of stuff, and works out what it needs to do with it based on what they call response plays. So I have seen this alert, I must do this thing. This thing can be call PagerDuty to get an engineer to go and look at it. That's probably what I see this being used for most, is it's just kind of this nice little intermediary so that you can use PagerDuty or probably VictorOps or whatever or anything else to get people out of bed. And I think it's AWS realizing that whilst Incident Manager can text people and send SNS notifications, other services are better at making sure people get woken up, right? Because at the end of the day, at 3 a.m, a text isn't going to get me out of bed. A phone call on loud is what's going to get me out of bed. So I think they've realised that PagerDuty and external services are better at that, for now at least. I'm sure it'll come, but for now at least, what they're saying is this service is the best thing that we can offer for collating all of your information and potentially automating responses to certain things. But PagerDuty is better than we can offer for getting people to look at stuff. So that's kind of what this is. Calling it automating your response with PagerDuty, I think, is a little bit generous, because my argument is if you're calling someone through PagerDuty, your response isn't automated. Potentially,
Yeah, but I think, when I read the article, it sort of spoke a little bit more about having the incident plans in place and everything else. So it's, whilst it's not automated, it's providing some assistance to the responder in how to actually respond to the incident.
It's one-stop shop, if you like,
yeah.
rather than, PagerDuty collating the alert and then you getting the alert and then you having to go to a wiki or to whatever to go and find it. It's kind of all in the one place, which is better. It is. Yeah. Of course, this is only any good if your alerts have come from within AWS, which they might not have done.
Yes, indeed. Yes, indeed. Although, CloudWatch can monitor things outside of AWS now, right?
Through Canaries, yes, but it's still limited.
Yeah, cool. Okay, conscious of time, so let's skip on to the final article of this week, which is one from our friends at the Register. One of their, as always, slightly controversial headlines. This one is about AWS expanding footprint at site of infamously flaky US East 1 region. Perhaps a little bit harsh, but certainly US East 1 has borne more than its fair share of outages in comparison to other regions. I think
wasn't it the first region that came online?
Yes, I think it's where AWS kind of started back in 2006. And I think, as the article says, it's they describe it as the most resilient region. But I think by that they just mean it's the biggest. It's got six availability zones and 10 local zones. But I think most of the outages that have affected the region have not been data center related. I think some have, but I think others have been more kind of code related.
Aren't they always?
From memory, I think there was definitely a power outage back in just before Christmas last year, wasn't it? Well, sorry, not last year, but 2020, before Christmas 2021. There was a big outage that emanated from that region. But it's great to hear that there's some significant investment going in there. $35 billion with a $140 million grant from the state, I guess. To help build out resilience in that region. So, what are your thoughts on this one, John?
I don't think the grant from the great state of Virginia is to help build resilience within their cloud platform. The grant is probably more to make sure that they employ local people, I would think.
Yes, yeah. More data centers equals more people racking, stacking, maintaining.
Yeah.
HVAC power systems and so on and so forth.
Yeah, it's saying it in the article, something like 1,000 new jobs, which is no bad thing. I wish they'd put some more of it here, but it's no bad thing, getting more people employed.
Absolutely.
Yeah, it's an interesting one. It's a funny one because Virginia has, I wouldn't say it's an unfair reputation for being the flakiest one, because it is the flakiest one, but it's kind of, I don't know, it's fun to jab it with a stick because it's the crap region and you just avoid the crap region if you can help it. But I think it's a factor of A, how old that region is, B, how big that region is, because you'd say, yes, it's got, 6 AZs and 10 local zones and all the rest of it. Surely managing all of that is an absolute headache. So maybe some of this money is going to making that easier rather than just putting more servers in warehouses.
I think it's also been a test bed for lots of new services and features.
It gets
I think
all
a lot
services
of the
first.
Yeah, and a lot of the global services tend to kind of run out of there as well.
Certainly to start with. I mean, it was fairly recent that AWS re-architected the support system to not run from there. So
yes, we spoke about that on an earlier episode of the podcast, I recall. Cool. Well, great to see that that the investment is going in there anyway. So let's hope that we all get to feel the return on that investment in the not too distant future. But that's all we've got time for.
$35 billion. Jeez.
Yeah.
I thought they were laying people off.
Yeah, they are, but they're still making ridiculous amounts of money, aren't they? So anyway, that's all we've got time for today, John. I know you want to carry on talking about this. I can tell you're keen. So perhaps we'll talk about it off air. But thanks, everyone, for listening. That's the end of episode 2, season 2, episode 4 of the LogiCast podcast. Thanks for listening, and we'll be back again next week with another episode for you.